All right, welcome to lessons 34 to 37. So lesson 34 today. So I'm just gonna kind of show you what we're gonna be doing now is graphics. So you can kind of see these are generally the way our graphs are gonna look here. Um, yeah, these two are the big ones, and then these ones start getting into like the tan graphs, and then just some of the weirder ones there. But let's get into it. So what we're going to do first is figure out what a sine function looks like. And the way we're going to do this, we could just like, plot each by each, but what I really like is this this Trig Explorer. What is it called? I forget what this one's called. Trig Tour. So there's a link to this on my website or on the workspace there. So I think it's definitely worth playing around with. So if I'm playing with this thing here, what I'm going to do is I'm going to put this to radians first. Oh, not draw. So I can put that to radians. I'm also going to put on, well, sine is the graph that we're doing right now. And then I'm going to put on special angles and labels. So now what I want you to see is this up here, right? This is our unit circle. And what you're able to do is grab, oh, maybe I have to grab some, oh, there. You're able to grab that line, or the radius there, and you're able to move it around, right? And it's showing you on the bottom here what the graph looks like. So for example, when our angle is 0, right? We have 0 degrees or 0 radians like this. On the graph, if I'm looking down here when I'm graphing this thing, then sine theta is equal to 0, right? And then one thing I want you to get used to too, this can be a little bit confusing, is that along the x-axis here, so pi and 2 pi and 3 pi, notice that instead of an x that we're graphing here, we're actually graphing theta. So it's the angle versus sine of the angle. So this sine of the angle, this is our y value, right? The same as it's always been. So here, if I move this thing up here, right? This is our y value. So right here, you see this green arrow showing you like how high this thing is on the y-axis? That's the same as like the opposite side of our triangle here. That is our y value, right? And if, from the unit circle, right, you can see that that would be a half, right? That's the y value right there. So when the angle is 30 degrees or pi over 6, then the y value is going to be a half, right? So that's kind of what you got going on there. This x value here isn't this. That's kind of what I was getting at there. Because like normally we're plotting x against y, but now what we're doing is we're plotting the angle against y, right? So the angle is going across the bottom and the y value is going up and down. So let's keep on going with the angles here. So that was our first point, right? Was at, so when the angle was pi over 6, our y value was a half, right? So if I move this thing up again, right? So now I'm at 45 degrees or pi over 4. What we'll see is that our y value is root 2 over 2, right? That's kind of what it's telling us here too, root 2 over 2. Okay, so hopefully that's making sense there. And then we'll move it one more. And now my y value should be root 3 over 3, right? That's the opposite side of our triangle there. So that's at 60 degrees or at pi over 3. And you can see, so if you plotted that, pi over 3, that's where it would be. Now, if we go straight up and down, right? Straight up and down, well, it's all y now. So if this thing is straight up and down, then sine theta is 1, right? Sine theta, remember sine theta is like y, right? So when you're going up and down, that's going to be our y value. It's all y when it's there. So that's why this is the peak of our graph, is at 1, right? It's right at the top. And then notice as we start coming around again, right? We go to the next one. This thing starts dropping now because now my y value is getting shorter and shorter, right? You'd expect that it would get even shorter, and then once we get to 180 degrees or pi, now our y value is nothing. So that's why it's nothing on the graph, right? And then you go around again, And you can see that y is getting bigger and bigger, but in the negative direction. That's why it's below the line over here now, until it's completely, like, as far as it can go, right? It has a y value of -1 because it's all in the y at that point. And then it goes around again, and then all the way back to where it started. So this is called the period. So the amount of time, like, so how far did it take for this thing to go from this point all the way up and then back to where it started again? That was one full loop around the circle, right? You kind of see that? If you went around here, that's one full loop. This thing would have a period, it said, of 2 pi. So one circle happens every 2 pi radians. Okay? So hopefully that's making a bit of sense. Now, if we go back to our grid here, well, we could start plotting this. Oh, that should be on this line. I don't know what happened there. Yeah, it should be right there, just so it lines up nicely. I'm not sure why that happened. So if we started plotting this thing, right, we could say, okay, at 0, it's 0. And then, well, we need to make our axes along the bottom here. I'm actually going to let you guys do that. You guys can do that. These numbers, right, that they're finding, those are all the exact same things that were on our trig tour. So right here, right, very first point would be at pi over 6, would be at, so pi over 6, right? That's that angle there. Well, you can see, if you go back to this, right, we'd have to label pi over 6 across the bottom there, right? Maybe I'll just help you guys label it. Maybe that's a good idea here. One sec. Oh, and sorry, actually, this one's saying it wants x to be in degrees, right? So the angle to be in degrees. That's the confusing part. Is it's not really x, right? It's actually the angle, not the x, which, yeah, can be a little bit confusing. So what I'm going to do for my angles, though, I'm going to go up by, so I'm going to make that 60. So we'll go up by 20 degrees each time, and then that'll be 120, and then 180, 240, 300, and then 360, right? And then I'll make 4 of them up. I'll say I'll make that 1, and then 1, 2, 3, 4 down. I'll make that -1. So what I'm expecting here, really, right? This thing's going to start here, where I'm right at the origin, and then at 90. So 90's about there. It should be at 1, right? At 90 degrees, sine should be at 1. And then I'm expecting at 180 degrees, maybe we'll make this a different color here. 1. It should be like that. And then at 270 degrees, it should be at -1. So that'd be about there. And then 360. And then you could fill in all the pieces and kind of figure out where they are, but in general, I'm expecting, well, that was terrible. That should have been the peak of that one. The graph should look something like this. That was kind of bad for that one. It should have been more like that one, I think. Yeah, so that's a sine wave. Okay? Notice the sine starts at 0, okay? Because now we're going to look at cosine. So cosine, if we go back to the trig tour here, I'm just going to change this to cos. And then as we're going around here, again, just kind of notice, right at this position, right? Well, my x value, right, or my cos value here, right? What cos theta is equal to? Well, that's going to be equal to 1 at the beginning, right? Because it's all x, right? The whole thing is x. That's equal to 1 whole arm at that point, right? Everything's in the x there. So you'd have a cos theta value of 1. So just as you flip back and forth through these things, notice the difference between them, right? Sine starts at 0. Cos starts at 1. That's important. You guys are going to have to remember that, or use the unit circle to kind of figure that out if you need to. Okay, and if I'm going around this, kind of show you again that, so now the x value, right, this one starts to go down, right, because it's going to get less and less and less as it approaches 90 degrees, and now the cos value or the x value is 0, right? There is no x value at that point. And then it's going to start getting bigger in the negative direction. So bigger, bigger, bigger until it's 1, right? Or -1 at that point. And then the x value will get smaller, smaller, smaller. And now it's 0 again. And then it goes all the way back to 1. So the period here started at that point, right? You can see that there. And then went all the way around to there. That would be my period for that one, right? The period is just where it repeats the pattern. So it started here, it was like on its way down, and then went back up here again, and then it would be on its way down again. So you could take the period as being from here to here, or you could have taken it as like here to here. It wouldn't matter. Either way, the period would be 2 pi. Okay? All right, so I'm going to leave that one. On the next page here. Everything's similar, but it's in radians this time, so the radians would be across the bottom instead of degrees. So it requires you guys to kind of think about fractions a little bit there, just to make sure you get them in the right place. But just remember, these things go up by, pi over 6 is 30 degrees, right? And then pi over 4 is 45 degrees. Pi over 6 is 60 degrees, right? So you can kind of go up by increments that make sense there. Oh, and just one other thing I kind of forgot in the last one here. I'll just kind of talk you through these ones. So x-intercepts, determine the following from the graph. Well, we kind of talked about these, right? The x-intercepts here are going to be at 0. This is for sine, by the way, right? 0, 180, and 360, right? That's where it is 0. The y-intercept, it's going to cross at 0, right? Amplitude. So amplitude is how far up this guy goes from the x-axis up. So this would have an amplitude of 1. It would be 1, or over here you could say it was -1. But with amplitude we really just say 1. It's 1 up or 1 down for the amplitude. The period, we talked about that, right? The period of both these graphs would be 2 pi or 360 degrees. The median means like the middle number. And that's really just what this thing is going up and down across, right? So maybe it'll make it easier if I drew a line here. It's going up and down, right? Around the middle number, 0, right? So y is equal to 0 is what the median would be there. That's going around that line. The maximum, well, it's going to be a maximum of 1 and a minimum of -1, right? So maximum just means the highest it's going to go, and the minimum just means the lowest it's going to go. So it's at 1 up there, and it goes to -1 down there. Okay, domain and range. Well, the domain of this thing is just going to be x is a member of the real numbers, right? This goes on forever. I probably should have drawn it this way more too. I just kind of started at 0, but it would go the other direction as well, right? This thing would go on forever in either direction. And then the range is going to be, well, y has to be less than, maybe I'll do it the other way. Y is going to be greater than or equal to something and less than or equal to something. Well, it's got to be greater than or equal to, well, the bottom number, right? It's got to be greater than or equal to -1. And it's got to be less than or equal to 1. That's as high as it ever goes, right? Okay. And then, yeah, there's some terms down here that kind of help you out there too. We're going to talk a lot about these as we go on, though, and do some examples. So just for the sake of time, I'm going to move through this one, though, because it's really similar. The only difference is that it's going to be cos, so it would start at 1, right? And then your graph would look, something like this, right? It goes like that, well, higher, but it goes that way. Okay, so let's do some of these questions. All right, so the amplitude of these questions can be determined from a graph by taking the max, right, minus the min, and dividing it by 2. So just to give you like a bit of a reference for that, right? You take the max, right? If I take my max point, so up here, right? My max minus my min, right? So my max minus my min. So that's going to be 1. And then, careful here, it's 1 minus -1, right? Because max minus my min. So that's really 2. And then 2 divided by 2 would give me my line here, right? Hopefully that, or sorry, would give me my height for this one. So max minus min divided by 2 is going to give me how high this thing's going to be. Okay. Okay, so there's that one. And then the median, or it's going to be our D value when we start doing like shifts and stuff. So remember like the plus D on the end was our Y value up and down, like how much it translated up and down. This will be that same value. So the median can be determined from the graph by going max plus min divided by 2. This one here, max plus min divided by 2, this is really just finding an average of two numbers, right? So what that means is if we go back to our trig tour, if I go my max, so this number, 1, plus my min, so -1, that's 1 minus 1, divided by 2, it ends up giving me 0. That's just all that is if you said, what's the average between, like, 6 and 9? Well, if I wanted to figure out what the middle number between those two was, I would go 6 plus 9 and divide by 2, right? That just to find the average between those two numbers. That's all we're doing, because the average between the peak of this thing, the max, and the min, is always going to be the line that goes right in between them. So that we want to find the average. That's all that number is. Okay, so that's the average between those to find D. Okay, and then since the period for both sine and cosine is 2 pi, or 360, then it can be found from the graph using, so this formula is on your formula sheet, and what P stands for is the period, right? So how long does it take to do one full rotation, or like one whole pattern on your graph? Your B value is gonna, remember that whole like C the B thing? It's gonna be the same thing. It's gonna be the number out front. So let's see if I can find an example down here just so you know. It would be this value, right? So your B value is gonna be the one that's attached to the X, if you were looking at like that number down there. All right, so let's do some of these. So it says, state the amplitude of each trigonometric function. Okay, just to make things easy, well, maybe not easy, but I wrote down, so you guys have seen this function, right? Other than I just put in sine of yada yada, normally we call that f of x, right, in all the other units. But now we're just talking about sine. So everything's the same though, like this will still be my vertical stretch factor, right? This will be my horizontal stretch factor. Oh, I forgot the plus part. One second. That should have been x minus, was it h? I call it h, what was it? Yeah, plus k. Okay. Okay, so that should look more familiar now. So if I want to talk about my amplitude, right? So it says state the amplitude of each trigonometric function. Well, if you think about this amplitude here, right? Like this will be our a value, because if you think about it, normally just the function y is equal to sine x, right? You can think about that as being like a 1 out front. Well, you can think that's my like base stretch factor. It's just starting at 1. But if you kind of like go back to your graph, right? This thing it starts out with 1, right? That is its amplitude, is 1. That's all it is, right? So if I multiply this thing by a quarter, well, my y value then would be a quarter of that, right? So in this case, like really, this one's kind of easy. It even says a, right? And that a really will be the amplitude in these questions. So this will just be 1 over 4. That would be my amplitude. Okay. So then this one, y is equal to -3 cos 1/2 times theta. Well, again, this one is just going to be, well, you can say -3, but really when we talk about amplitude, it's like the absolute value. So it's just going to be 3. Because it'd be 3 up or 3 down. It doesn't make much sense to say -3, because it's a scalar if you guys are in physics. It's now the vector. Okay, state the period of each trigonometric function in degrees and in radians. All right, so the period. Well, as long as we know this, that this is my b value, right, in this function. It doesn't matter that it's cos. It's sine and cos are just the same thing, right? It doesn't really matter. So that'll be my b value. And you guys have a formula in your formula sheet that says this. P is equal to 2 pi over b. Okay? Well, easy enough then, right? I can figure out what my period is here. It's just going to be period is equal to 2 pi over, my b value is 2. So 2. So my period is equal to pi. And we all know that pi is equal to 180 degrees. Okay, so that means this thing would go up and down and up again, like do with one full rotation in pi, right? Which kind of makes sense. It has a horizontal stretch factor of what? Remember, these things are backwards. They have a horizontal stretch factor of 1 over 2. So that makes sense. Normally the period's 2 pi. Now my period's only pi. So it's been stretched by half, right? All of those things have been stretched in, or squashed in, however you want to think about it. Okay, so if I'm looking at the next one here, so this will be my b value, right? So that's my b value. So if I go, okay, well the period is equal to 2 pi over, now I could put in 1.5, that'll work, but I kind of want to keep it as fractions here, so I'm going to call that 3 over 2, right? 3 over 2. And then if we rewrite that, I'm going to rewrite that as 2 pi and then flip that one around, right? So I call that 2 over 3, just dividing by a fraction, same as multiplying by the reciprocal. So that just ends up being 4 pi over 3. Okay, and 4 pi over 3 on the unit circle there ends up being 240 degrees. You could multiply, you could figure that out by so multiplying by, well, okay, let's do it. So 4 pi over 3, and I'll say that's equal to, and let's go, okay, rewrite that a little bit. Let's go x, if I'm looking for in degrees, right, over 4 pi over 3 is equal to 180 degrees over pi radians there. Okay, so I could rewrite that as 3x over 4 pi is equal to 180 degrees over pi. I can see that my pi's cancel. And x would be equal to 180 degrees times 4 divided by 3, which would be equal to 240 degrees. But if you had it on your unit circle, or figured out in your unit circle, you could have just known that too. So, all right, almost done. So number 3. So it says find the period and amplitude of each trigonometric function. So now we just have the graph, right? So the amplitude, right, it tells you at the very top here, it's at 0.5, right? And then it goes down 0.5. So my amplitude is going to be 0.5. Right? Now, if I want to find my period, right, period, then it doesn't actually, because I can see it goes through 0, 0, or I think it does anyway, it's pretty close, 0, 0. And then the period would be to here, right? That's one full, you know, repeating the pattern. Well, I don't have this number, but they did give me that number. Well, this one, right, if I want to know the period of this thing, it's just going to be that times 2, right? It would be this distance and then times 2 to get me to there. So I'm just going to go 4.71, just the number they gave us there, times 2. So the period in this case is just going to be 9.42. Okay, that's it. Now the next one, the amplitude on this guy is going to be, well, just 2, right? It goes up 2 and it goes down 2. So it's going to be an amplitude of 2. This would be our, if we put this into an equation, this would be our A value, by the way. Okay, and then what else do we know here? So we know that this thing starts here, right? And then it does half of its period to 60. Because if I went from the bottom to the bottom there, that'd be one full period, right? So if I go 60, which is half of it, right? Because you could split that thing in a line, then that would be my full period. So I can tell my period is going to be 60 times 2, or the period is going to be equal to 120. I think that's in degrees. Yeah, it must be. Okay. Yep, so that'd be it. All right, so I think... Oh, no, I got more. All right. Okay, so we're going to graph some things now. Again, this line should be lined up better. I don't know what happened there. Should be there. Oh, okay, that wasn't much better. All right, so what I'm going to do is so we've got this graph, right? I'm going to kind of show you the original graph. So if we just have y is equal to sine theta, right? What does that look like? Well, we kind of talked about this. Start at 0. And what I'm going to do, I want to make space for both of them. I'm going to look at this 1 over 3, right? That's my b value. So if I want to know my period here, so do one full rotation, it's going to be 2 pi over b, right? Or period is going to be 2 pi over 1 over 3. So if I flip that all around, the period in this case is going to be 6 pi. So I need to at least go up to 6 pi on my x-axis, right? Or on my angle axis. So what I'm going to do is I'm going to make every 3, so 1, 2, 3 equal to pi. So pi, 1, 2, 3, I got 2 pi. And then 1, 2, 3, I got 3 pi. 1, 2, 3, I got 4 pi. 1, 2, 3, 5 pi. 1, 2, 3, I got 6 pi. All right, so that's going to be my scale that way. And then I'm going to make 4 up. So 1, 2, 3, 4. That'll be my 1. And then down 1, 2, 3, 4. That'll be my negative 1. All right, so normally this graph starts at 0. Maybe I'll make this one green. So it starts at 0. And then it would go, well, it's going to cross at pi, right? And then it would come back down around there. So right at pi over 2, so right in the middle of these guys, this thing would go up, come there, and then it would come down, again through there, and it would continue on with this pattern all the way around. And then up, right? All right, so that's what it would do the same the opposite way too, right? It would come down, go back up again, and yeah, do the same that way. All right, so now we're going to do y is equal to sine of 1/3 theta. Well, looking at this, right, this means that we have a horizontal stretch of what? A horizontal stretch of 3, right? That's our b value. And what that means is every one of these x values, right? So this x value here, like every point on this graph, is all going to be stretched 3, right? 3 that way. Everything will. So I know that this point, well, let's say pi. Let's do the ones on the x-axis. That'll be the easiest, right? This point at pi right here, right? That will now be at, well, 3 pi, right? Pi times 3 would be 3 pi, right? This one that was at 2 pi would now be at 6 pi, so it'd be over there. So I shouldn't actually, just so we're not confused, let me take that one off of there. Oop. And I should probably take this blue one off of there too. Okay. So you can probably, now that you've got those lines there, there is no like vertical stretch factor, so I can kind of tell if I go right in the middle of these points, right? It's probably going to be right there is going to be the peak. And it's probably going to be in between those two ones. It's going to be down at 1 would be right there, right in between 4 and 5 for that one. But we can make sure this actually works out, right? If I took, I'm going to do a different color here. If I took this point right here, right, that one, this was pi right there, right? This was pi over 2. Okay, well what I'm doing is I'm going pi over 2 times 3. So this next point should be at 3 pi over 2, right? Well, this is at 3 pi over 2, right? That's at like 270 degrees. So that's where this point got shifted to. It got shifted over to that one. And it would work out the same for all of them. So you can, so hopefully you can kind of see that. And then we just would connect the dots, right? And what I would do if I was you guys and you were drawing these things is I would pick points that are pretty easy to deal with, right? Like this pi over 2 is a nice one to deal with. This, the 0 is the ones that are actually on the x-axis. Those are kind of nice to deal with. But that's a general idea. Hopefully that made sense. The other way that we could do it that's kind of useful, especially if you get a bunch, is to use our mapping notation, right? So hopefully maybe you guys remember this. We said, okay, the point xy, where is the point xy going to go? Well, this means every x value, 3x, and then y, right? Every x value is multiplied by 3. So then you could just do that. And remember, when I say x, I really mean the angle in this case. So 3 times any of these angles would get you to where you're going to be, right? The y value stays the same, and the x value, or the angle, every one of them gets multiplied by 3. Okay? This mapping notation might come in handy when you start getting ones like this, right? That have a few things to do. So let's sketch this one out. And we'll do this one in degrees. Didn't tell us what to do, so I'll just do it in degrees. So let's go. This will be, I'm going to call this 10 degrees. Here, I'm going to draw that a little different. 10 degrees, 20, 30, 40, 50, 60, 70, 90. Okay, so we got it looking like that. Oh, and maybe you're wondering how I got those numbers, right? What I would do again is I'd be looking at this b value, right? And I say, okay, well my period is going to be 2 pi over but just wait, it won't be 2 pi because we're dealing in degrees, right? So instead of 2 pi, what I'm going to do is say 360, right? Because 360 degrees would normally be my period. So it's going to be 360 divided by 4. So my period here is going to be equal to 90 degrees. Okay, so that's why I went up to 90 on the side there. Sorry about that. Okay, I got a class coming, so I'm going to pause this. But you know what? For the sake of time, since I'm not going to be able to continue on with this video, what we're going to do, I'd like you guys to actually figure this one out. I'll help you out though. Looking at this one, we've got a horizontal stretch of, 1 over 4. Horizontal stretch of 1 over 4. We've got a vertical stretch of 2. So vertical stretch of 2, right? And then we've got a vertical reflection, like in the x. Okay, so what I think would be handy for you guys then, start out with a mapping notation, and then using these, figure out where all the points would be, and then sketch it out for me. Alright, so I'm going to let you guys do that.